Picture this. You're sitting in your Cambridge Biology 9700 Paper 2 exam. You turn the page, and there it is, a high-value question on penicillin. You smile, right? Because you know the biology inside and out. You write this beautifully detailed paragraph explaining exactly how it works. You put your pen down feeling absolutely confident. Then a few months later, you get your results, and you scored a solid 0 on that exact question.
It's literally a devastating scenario, and honestly, as an examiner, I see it happen all the time. So why do brilliant students consistently drop easy grades here? It's definitely not because they don't know the underlying science. It's because they completely miss the specific analytical frameworks that Cambridge examiners actually demand. They end up giving a superficial textbook-style summary when the exam is specifically hunting for evaluative depth.
15%. That is roughly the percentage of total marks this specific topic, penicillin's action on bacteria and why antibiotics don't affect viruses, typically accounts for in Paper 2. Think about that. It is a massive chunk of your grade boundary. So consider this explainer your essential survival guide to locking down every single one of those marks. Okay, let's dive into this.
All right, before we get to the exam strategy, we have to make sure our core concepts are completely bulletproof. We need to look at the biology, but specifically from an examiner's perspective. Let's lock in the exact definition. Penicillin is an antibiotic that specifically disrupts the synthesis of bacterial cell walls. Now, you can't just say it kills bacteria in some vague way. That's a low-level answer, and you will lose marks. The exact mechanism is that it targets and physically weakens the structural integrity of the cell wall as it's being built. Without that rigid protective wall, the bacteria just can't handle the osmotic pressure. They swell, they burst, and they die. It's a highly targeted, highly specific attack.
And you know, this perfectly brings us to the next major hurdle, the distinction between pathogens. Why on earth are antibiotics completely useless against viruses? Well, when you compare the two, bacteria have that vulnerable cell wall for penicillin to target. Viruses, they have absolutely no cellular structure. Actually, scratch that. They don't even have cell walls to begin with. They're essentially just genetic material wrapped up in a protein coat. They rely completely on hijacking a host cell's machinery to replicate. Because of that, penicillin literally has no target. The virus is completely unaffected. Examiners are actively hunting for you to make this precise distinction using this exact terminology.
Okay, so knowing the biology is great, but that's really only half the battle. Let's raise the stakes a bit and shift from pure biological theory to the actual procedural frameworks. How do we actually pull those marks out of the mark scheme? I absolutely love this quote pulled directly from the principal examiner reports. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Whenever you're dealing with data interpretation in your exam, top marks are awarded for the process, not just your final mathematical result. Your working is literally your absolute insurance policy.
To guarantee you get those method marks, Cambridge expects a very standardized problem-solving sequence. Step 1, you deconstruct the question. Step 2, extract the relevant data from the stimulus materials. Step 3, select your analytical framework. Step 4, execute with clear notation. And Step 5, present it all with correct terminology. Now, Step 3 is where things get really interesting. In just a minute, I'm going to show you a hidden examiner clue tied directly to selecting that framework that completely changes how you answer. But first, we need to make sure the rest of this framework makes sense to you. Let's look a bit closer at the analytical side, because data interpretation is absolutely crucial here. When you pull data from tables and graphs about antibiotic efficacy, you have to apply the correct statistical test. It's non-negotiable. Say you're comparing the means of two different antibiotic treatments, you'd use a t-test. Dealing with categorical data, like grouping bacterial resistance, that's your chi-squared test. And if you're trying to figure out relationships between variables, maybe penicillin concentration versus bacterial death rate, you need a correlation test. If you select the wrong test here, you instantly bleed method marks.
Let's put this into practice and snap into active learning mode. I want you to step into the examiner's shoes for a second. Let's do a little interactive challenge.
Look at the flawed student answer first. Notice how vague the details are? It just says the antibiotic worked better. It completely misses the units of measurement from the graph, and it totally lacks scientific reasoning. It's that classic trap of going for superficial breadth over analytical depth. Now, look at the top band, perfect answer. See the difference? It explicitly states the concept. It extracts exact numerical data, includes the correct units as evidence, applies real scientific reasoning regarding cell wall synthesis, and uses exact examiner terminology. This candidate deconstructed, solved, and evaluated perfectly.
To make sure your answers always look like that perfect one, we really need to look at what Cambridge is officially warning us about in their highly exclusive principal examiner reports.
Here are the top 3 red flags that will absolutely tank your score. Number 1, vague details. Examiners despise generalized statements. They want to see specific, connected, conceptual understanding. Number 2, missing units and sloppy terminology. Failing to check your units when calculating data is just a massive unforced error. Don't do it. And number 3, ignored context. The whole syllabus emphasizes transferring principles to unfamiliar contexts. If you just recite memorized textbook facts without applying them directly to the specific experiment they gave you in the prompt, you will be penalized for sure.
Now, avoiding those basic traps is great, but there is an even higher level of evaluation required for the hardest questions on this paper. This is what we call the hidden mark killer.
When an exam question asks you to evaluate the quality of evidence or do a comparative analysis, like comparing the effects of penicillin on 2 completely different strains of bacteria, you have to follow a strict formula. Comparative analysis requires identifying both similarities and differences. You must use comparative connectives, words like whereas or conversely. And crucially, every single comparison has to be backed up with hard evidence and data extracted right from the prompt. You aren't just summarizing, you are evaluating alternative interpretations and drawing justified conclusions.
But guys, here is the ultimate trap. What if you do all of that? What if you know exactly how penicillin targets the cell wall and ignores viruses? What if you show you're working perfectly, you evaluate the data flawlessly, you double-check your units, and you still score a 0? How is that even possible?
Remember that hidden examiner clue I promised you earlier about selecting your framework? Well, here it is. The secret lies entirely in the command words. If the question says evaluate and you just describe, or if it tells you to calculate and you just explain, it doesn't matter how beautiful or scientifically accurate your answer is. It's completely useless. Without understanding those specific command words, even the most perfect framework will have you answering the wrong question entirely.
Those command words are the true gatekeepers to the highest possible mark bands, and you really cannot afford to misunderstand them. So, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. In our next masterclass, we are going to completely decode those exact command words so you never leave another easy mark on the table. See you there!